Now we are finally at part 6. We will solve more examples and to practice more and understand the method more, okay? So let's enjoy solving now. So you have integral 1 to infinity, okay, 1 to infinity, x plus sine squared x plus 3 over x squared plus 2x plus 1 dx, okay? Note here, x plus sine squared x plus 3 over x squared plus 2x plus 1, okay? We'll use conversion theorem. Let's use conversion theorem. So this here is greater than or equal to, I want to make the fraction less than the original one. So minimize the numerator, maximize the denominator. How to minimize the numerator? Delete these positive values, okay? You get x. Then maximize this thing, the denominator. You get x squared plus 2x squared plus x squared, because we are maximizing it. Maximizing the denominator, I mean. So x over 4x squared. You get 1 over 4x. This here, x over 4x squared. From this one here. So you get 1 over 4x. Now you use that nice conversion test. So here, this here b equals 1 less than equal to 1 divergent. So you get here this one also divergent. Now the next example. What's the next example? Yes, it's here. Now here you have integral 1 to infinity x square root of x plus 5 over 2x squared plus 3 cosine squared 2x, 3 cosine squared 2x plus 7x plus 9 dx. Good? Yes, it's of course it's good. Now, so we have this. We want to use that thing, the test called that is called conversion theorem. Okay. Again, this here is greater than or equal to. Okay. So minimize over maximize. So minimize. To minimize this, just keep the x square root of x. Here below, maximize. So make all of them x squared. So 2x squared plus 3x squared plus 7x squared plus 9x squared. You maximize every part. You get x square root of x is x to 3 over 2 because x is 1.5. Now below we have 21x squared. 21. You get 1 over 21 x to 0.5. 0.5 b equals 0.5 is less than or equal to 1. So divergent. Okay. Yes, it's okay. So the original one is divergent by comparison theorem. Now, the next example. Now you have this one. Now you have integral 1 to infinity sine square x over 1 plus e to x dx. Yes. Now, sine squared x over 1 plus e to x, this here is less than or equal to, here many, no, here maximize and here minimize because we want to make the fraction bigger, right? So this is less than or equal to, less than or equal to 1 because sine squared is less than or equal to 1 over minimize now. Just put x squared. Why? Because x squared because x squared is less than or equal to 1 plus e to x for all x greater than what? Nearly there exists value such that for all x greater than it, we will have this equation true. How to decide this value? Use calculus 1. Use first derivative test and these things. But here I am sure for what values? Let's see for all x is greater than 2. This equation is true. So now divide, you get 1 over 1 plus e to x less than or equal to 1 over x squared, and you get that one above. So now let's write the result. This one is convergent. Convergent. And so the original one is also convergent. Now let's solve. Now we have this one. Integral 1 to infinity 1 plus sine squared x over ln x plus 2 square root of x plus 1, 19. So dx, okay? Now we will use conversion test again. So now we have 1 plus sine squared x over ln x plus 2 square root of x plus 19. So this here is greater than or equal to minimize, maximize. So we need to minimize. Just remove this positive value here. If sine squared, it's 0 or positive. So this is greater than or equal to 1. And maximize here. You get square root of x plus 2 square root of x plus 19 square root of x equals 1 over 22 square root of x. Okay. Yes, 22, it's right. Now what? So here, b equals half, because x to 0.5. Less than or equal to 1, so divergent. So the original one is divergent. Now let's solve integral 1 to infinity square root of x plus 3 x plus ln x to 7, okay, plus 5. Good. Good. Try to solve this one. Now let's solve it together. Okay. I mean, stop the video if you want to try and then check my solution. Okay. So now we have square root of x plus 3 over x plus ln x to 7 plus 5. Good. Now this is greater than or equal to minimize, maximize. Okay. Here to minimize, this is greater than or equal to 3. Okay. Because square root of x is positive and 3 is positive. You can put here if you want square root of x, it's true. Or 3. I want to put the 3. I love the 3 more than square root of x. Here to minimize, go to minimize. I mean maximize, sorry, maximize. To maximize, put all of them x. X plus 5x, you get 3 over 7x. So b equals 1 less than or equal to 1, divergent. And the original one is divergent. It's very cool. Divergent. Good. Now, wow, there are many problems. Let's solve this one. 3 to infinity 5 plus ln x to 21. Okay. What do we have now? We have x squared plus 3x plus cosine squared x plus sine squared x. No, sine squared plus sine squared will be just 1. Say plus 5. Okay. Dx. How to solve this one? 5 plus ln x to 21 over x squared plus 3x. Okay. plus cosine squared x plus 5. Okay. This here, let's write it. Let's have some space. Okay. This here is less than or equal to, it's greater than or equal to 0. Okay. And it's less than or equal to, so maximize, minimize. Good. Good. How to maximize such thing like this. We said that ln x any power less than or equal to x to any power. So let's say let's say 5x to 0.3 plus x to 0.3. Okay, over what? Over that thing. Minimize now. X, use x. So x plus 3x plus x plus 5x, you get that thing. 6x to 0.3 over over 10x. You get 6 over 10 times 1 over x to 0.7. And that is not correct. So what's the problem here? See, you should try and think. So I need to give it another try. What's the problem here? Yes, I have another idea. So we want to minimize the denominator, right? These here are all positive. Here, I put I have here, okay? These are positive. So just remove them, okay? So x squared. So you have minimized it. So this equals 5 over, 6x to 0.3 over x squared equals 6 over 1 over x 1.7. B equals 1.7 is greater than 1, so convergent like this. Convergent, okay? So the original one is convergent, thankfully. I don't know why thankfully. I mean, what's the problem? If it's divergent, what's the problem? Wow. Now the last one, because I got tired. But will any one of you watch the video until this point? If you reach this point in the video, write yes, I have reached. Okay. X minus sine squared x plus 17, for example, over what? X squared minus 2x plus 3 dx, like this, just like this. X minus sine squared x plus 17 over x squared minus 2x plus 3, and this is greater than or equal to minimize, maximize. So here, when you want to minimize, what should we do now? We want to minimize, right? Here we have 17, right? We have 17. So if we remove it, we are minimizing. So we get x minus sine squared x. Below maximize, you get x squared plus 2x squared plus 3x squared. This equals x minus sine squared x squared, how much? is 6x squared. I need more space and to think how to continue. Now, again, greater than or equal to max, I mean minimize, because here minimize when you want to make it less. Minimize, maximize. How to maximize? How to minimize it? This one, keep it as it is, just 6x squared. For the one here, x minus sine squared x, it will be x minus 1. Okay, because the largest value of sine squared is 1. So the least value of this one is x minus 1. Okay, because when you subtract, you are making it less. So x minus 1 is the least value of it. So now this one equals 1 over 6x minus 1 over 6x squared. Good? Yes, it's good. Here, convergent, divergent. Divergent because b equals 1 less than or equal to 1. Now, divergent plus convergent, divergent. So the original one is divergent. Great. Nice. Let's stop here. Please like and subscribe and write your opinion about the videos. I wish these videos will benefit you. Good luck.